Hi everyone. Today's video is going to be on systems of equations with no solutions. So first we're going to look at an easy example, then we're going to look at a little bit more complex example, and then we're going to end it off with a try it yourself so you can check if you learned the concept and the little trick I'm going to show you. So first we're going to go over the long drawn out concept, and then I'll tell you the short trick to do. Okay, so first we'll do the long concept. So there are two ways to imagine the concept in the first place. So a system of equations, if you didn't know yet, is where you try to find where two lines intersect or two curves. This situation, for SAT purposes, we're usually only going to see linear systems of equations, so I only gave you linear examples here. So first, we'll start by formatting them in slope-intercept form. So slope-intercept, and that is y equals mx plus b. So y is obviously the y value of the point. M is the slope, x is the x coordinate of the point, and b is the y-intercept. So how do we get it to this? We just simply subtract x from the left side and the right side of the top equation, and we get y equals 0 minus x. So then we get y equals negative x plus 3. The other equation. So we get y equals minus x, and we get y equals plus 5. So we can now imagine this as the system of equations. So now we need to figure out if these intersect or not, and if they do, where they intersect. To help you visualize this, I've put it on Desmos, which is a graphing resource you can use when you need math help with graphs. And as you can see, these two equations don't intersect. Now, why is this? Now, this is what we call parallel lines. So that's when the slope is the same, but the y-intercept is different. So if you look for this one, m equals -1 for the negative x plus 5 because m is -1, and the same for the top one. So the slope is the same for both. B, the y-intercept, is different for both of them. So you have 3 for one and 5 for one. So there will be no solution to that equation. So now here's a quick trick. You can look at the coefficient of the equations in the system of equations. And if the coefficients are the same, say 1, 1, 1, 1, but this value or the constant is different, we can conclude that the system will have no solution because the line will be parallel and you won't be able to find a point of intersection. Now this is a quick tip just to get you through all these problems so you can just check the coefficients. If the coefficients are the same, then you check the constant, and if the constant is different, we get no solution. Okay, so now we have a bit more complex of an example. In this one, the coefficients aren't giving you the same, but you can see and look that they are multiples of each other, as 2 times 2 is 4 and 3 times 2 is 6. So now we simply have to make the coefficients equal to each other for this equation to solve it, at least one of them. So we'll just try making the x coefficients equal. So how do we get 4 from 2? We multiply it by 2, so times 2. So we're going to multiply the left side of the equation and the right side of the equation by 2. We're going to get 4x plus 6y equals 8. We can compare this to 4x plus 6y equals 12. Now let's use a trick that we just learned. We can see that 4 and 4 are the same, and we see that 6 and 6 are the same. So now all we have to do is look at the constant, which is 8 and then 12. So these two constants are different, so we know the lines are parallel, and we know now that the system of equations will have no solution. So one question I commonly get is, does this only apply to equations where it's x plus y and x plus y, where there's no coefficients in front of the variables? And in fact, it does not. This applies to any coefficient If the constants are different and the coefficients are the same in the system of equations, you're going to find that there's no solution because they are parallel lines. So we can just do this one really quickly. 6 is same as 6, 5 is the same as 5, 3 is not equal to 4, so we can conclude that it has no solution. The lesson, as you can see, this is this really simple trick, and it'll help you out a lot on the SAT. I speak from experience. I see systems equations really, really often, and being able to do a problem like this very quickly and moving on to harder questions will really help your score out. I hope you learned something, and I'll see you in the next video.